So this is our second attempt at the top problem. As you can see here, we've clarified our diagram a little bit. We introduced the Earth fixed reference frame E with the I hat, J hat, and K hat axes, and then we have the top, which is precessing around the Z hat or the K hat Z axis in the Earth fixed reference frame at an angular speed of omega. The top is also at an angle, the axis of symmetry of the top is at an angle alpha from the z-axis in the Earth fixed reference frame. So we introduce an intermediate reference frame, which we can just call I for intermediate, and it's rotated about the x-axis of the Earth fixed reference frame at an angle alpha. So you can see we have our new coordinate axes, I prime hat, J prime hat, and K prime hat. And we know that the top is also rotating around its own principal axis in its own reference frame at a speed, or rotating, not in its own reference frame, but at a speed psi dot.
Let's see if I can.
Cool. So then our approach was to use this form of Euler's formula. We can see that we can relate the moments to the angular speed of the top with respect to the Earth in our intermediate reference frame. And then to simplify this expression, this generic expression, we're going to cancel out this term because we know that the omega of the top and its rate of spin are constants because it's precessing steadily. So the rate of change over time of omega is just 0. So that'll simplify our process. Then the first thing that we can do is find the moment that we know that gravity exerts a moment that pulls the top downwards towards the Earth. So to find that moment, we want to find, this is a cross product. We want to find
The center of mass
of the cone because we wanted to choose the center of mass as our point of interest for Euler's formula, since the center of mass of a cone and the moments of inertia about its center of mass, moments of inertia about its center of mass are well known. So we know based on the assumption that this cone has a uniform density that its center of mass is going to be located 3/4 of the way along its principal axis.
So we can write that as 3/4 h.
3/4 h because it's times the height. And this is going to be, I believe, in the K prime hat direction. And then the force of gravity is going to be equal to the mass of the cone times our constant g. And then this is going to be acting in the downward z hat direction in the Earth fixed reference frame. But we want to find the moment as defined by the intermediate reference frame. So we're going to have to do a conversion here. We can see that a component of the gravitational force, which is acting downwards on the top, is acting in the J prime hat direction, and a component is acting in the negative z prime hat direction. You can see our vector triangle. And so in order to find how much of the component is in each, we can look to our angle alpha. And we know that I believe the z prime hat component is going to be sine of theta, while the this is j hat, while the component in the axial direction of the top is going to be in the k hat direction. Gracie, do you want to do this cross product?
Yeah.
Alright, cross products, my specialty. So we're just going to set it up like this. So I hat prime, that's almost dead. So I hat prime, J hat prime, and K hat prime. This is what it's about. So this first one is in the k hat direction, so we're gonna put a 0 in the I and j, and then 3/4 h in the k hat, and then I was gonna erase this once
I
I'm
think we
done.
can erase it once we're
It's
done.
gonna get
with that.
erased. So this mg, I'm gonna distribute it, so it's gonna be, this is j hat, yeah?
Mhm.
So 0 in the I hat, mg cosine alpha, that's alpha, and the j hat prime direction, and then we're gonna have also mg sine alpha in the k hat direction. So to do this, nothing in this direction, so we're gonna start with I. So we're gonna do 0 times the mg sine alpha minus 3/4 h times mg cosine alpha. So this becomes 0, so it's gonna be negative 3/4, make sure that negative sign is there, h times mg cosine alpha. And then in the j hat direction, because these are both zeros, we're gonna have nothing, so 0. And then in the k hat direction, the zeros also are in 2 of them, so it also is 0. So in the end, we have the eraser.
You're gonna want to move it up?
Yeah, just erase that.
One thing I just noticed, I think I forgot to put that the force of gravity acts in the negative k prime hat direction, so it shouldn't affect the end result of our cross product, but no.
You're saying they should be negative? Because it's acting downwards, is that what you're saying?
Because it's acting inwards towards the origin.
Right, so this will be negative, but
Yeah.
we don't really
It's
ever.
a term away.
But it won't affect the cross product.
Okay, so then this becomes negative 3/4 h times mg cosine alpha in the I prime hat direction. Erase all that.
All right.
So what's next?
The next step, we need to define our omega of the top with respect to the Earth in the intermediate reference frame, and we need to write out our moments of inertia matrix.
Okay, so anyone want to write out that, or I can do it real quick?
The moments of inertia?
For the moment of inertia, is it just going to be a diagonal matrix?
Yeah.
It should be, because the top has two axes of symmetry, or two planes of symmetry.
Do we want to write it
The
as
products of inertia are zero.
It's gonna be equal.
Equals.
And then.
You can. I think you
This
can.
one would be. Should we find this one first? Because this is the matrix.
Yeah, we can do either first. It doesn't matter. We all have to do both in the end.
What are we trying to do?
Find omega of the top with respect to the Earth.
Let's do that first.
In the intermediate
We'll do
reference
the
frame.
later.
Okay. So omega on the top with respect to Earth, we want.
I believe we need. Do we need a rotation matrix for this? Is that right?
If we did use that.
Yeah.
Last time we used that,
Okay.
and that I think.
I have a picture.
I can pull this line.
That way- So
That was what we got.
Yeah.
Are we sure that's right? The matrix that we used to get.
Let's see if we can pull it up
Wait,
just so.
rotation, I think last time we used this one.
Yeah.
So
That's for rotation.
we're gonna write it down here so eventually it'll come up.
Correct.
But the rotation matrix.
Rotation. We're rotating about the first axis.
So it'll be that T1
So it'd be the
theta.
first.
And would it be
matrix.
in terms of theta or would it be in terms of
Theta is the rotation angle, so in our
Right.
case it's alpha.
alpha? That's what I thought. Okay, cool. So we're just gonna write it down here and eventually bring it up. So this is in terms of alpha. And then this is TE or intermediate. It's intermediate, right? Yeah, we might need a different one. Intermediate with relations to Earth. So this is gonna be E, and then all this is in the inertial frame. Cool. So here we have our matrix is 1, 0, 0, 0 cosine alpha, and then sine alpha. And on the bottom we have 0, negative sine alpha, and cosine alpha. And so,
And then
yeah.
we know that our the angular velocity of the top in the Earth reference frame is just about the z-axis at the angular speed omega.
So just this.
We can,
Yeah. Isn't it?
yeah. So let's write the vector next to the matrix. I think.
So it's gonna be 0 plus. Are we? We're just gonna put.
Hold on. I think I need you to write the omega vector because we're transforming the vector with the
So you're
transform
multiplying
matrix.
the
Right?
matrix that you have by whatever the omega thing is.
Oh.
Is it going to be about our z hat, right? So this would be like
Mhm.
So
the
it's
0,
gonna be.
0. It's a column matrix. So it's your I 0, your J 0, and your K is going to be your. It's going to be your.
It's our omega.
Is it just omega?
Is it just omega?
I think it's just omega. Because this is the angular velocity.
What are we? What
This is the angular velocity from the rotating motion around the z-axis.
Is that? That's what we're. That's just what we're calculating right now.
Yeah. And then we also know that there's an additional rotation about
Yeah.
the top's
Are
principal
we
axis.
gonna calculate that separately?
I think we can add them together,
Because,
yes?
Well, last time we did it, we combined. both
I don't
times.
think that was right.
Well,
Though.
last time we did it wrong. Do we have the eraser? So this is what we get off of that. And then, are we gonna do it a second time for the?
I don't think. Well, we already know the angular velocity around the top's axis in the intermediate reference frame because it's just psi dot k prime hat. So I think angular velocity is additive, correct?
Yes.
Yes, it is. It's in the same reference.
This goes here, yeah.
And
It's-
now
it's
they're in the
additive.
same reference frame.
It is additive.
We have units that we need. No, not yet.
All right, so then let's add our spin.
So.
So that's another vector.
So what
Plus.
are we thinking?
Matrix.
That's-
Column matrix, right?
So we're gonna bring.
Yeah, just
No,
a
first
vector.
we're fully making the angular velocity. We're adding more angular velocity.
Okay.
So first we translated it, now we're gonna include the rate of spin. So we added a matrix, right?
Oh, okay.
So the rate of spin is just about the k prime hat axis.
Yes.
So then it would be a
0,
column.
0,
Yeah.
Mhm.
0, 0, 5.
And then the speed is what we're solving for.
side.
That's psi dot.
Okay, cool. So then, can we just add those together then?
I believe so.
So then, this total would be.
0 to I.
Can I just? I'm just gonna do
Yeah.
this. Side. Dot.
It's
Do we
it's
have to
added,
add
right?
This-
Plus-
Yeah. Okay. Cool. So now we have
That's the expression.
the expression, and we can put that on the right too of the matrix. But we need to find the moment of inertia matrix.
Yes.
Someone want to write the moments of inertia of a cone?
It's gonna be just diagonals, right?
Mm-hmm.
Is this supposed to be sine or cosine?
With the cross product, you get cosine.
I think it's cosine, but maybe we should check.
I can do the cross product again on my iPhone.
Maybe the way
You think the way we set it up?
that I wrote the force of gravity vector was not correct.
So it's gonna be a fully diagonal matrix. I have, I think all of them on the diagonal component are the same, right? They're all
I think you're right, Andrew.
in order 20.
Yeah.
So if you look on the board, it's gonna be, well, it's blocked by Z, but so it's gonna be all like IXX, IYY, and IZZ. No, IZZ is different. So this
Yeah.
is
Yeah.
weird.
Yeah. The x and y are the same.
Yeah. The other ones are 0, and I think the reason for that is because we're seeing that it forms a plane of symmetry,
Yeah, it has two planes of symmetry.
making the non-diagonal terms to be 0.
Mm-hmm.
We do really small notation.
should we immediately cancel mass, or should we wait until like we hit the cross point first and then do that?
I
We
think
should
that
wait.
we should wait.
That's
Something
probably
about
more
notation?
proper.
Oh, it's just the parentheses when they be the circular ones instead of the.
My bad.
I don't
My
think it really
bad.
matters.
No, I'll do it.
I messed up the force of gravity vector. Need to do the
If you
proper
give it to
rotation matrix. Someone can write it on the board, or I can try again on the board if someone
Where?
takes over the camera.
If you
What
tell me,
happened?
I can do it on my iPad,
Well,
and then you can just put it up.
is it not just like switching J high and K high?
No, that is not.
Well,
that's
like-
not the problem. Unfortunately,
What was the mistake?
I think it's supposed to be sine instead of cosine.
Right.
I didn't apply the rotation matrix to change reference frame. I kind of just did it wrong in my head. So we know it's the rotation matrix you had before.
One,
Can you remind me what it was?
one at the top, and then cosine alpha.
Cosine alpha, sine
Sine
alpha.
alpha, negative sine.
Cosine.
Okay. And then now.
One.
Negative f.
Just switching J and K high.
I think that's probably what it ends up being. But
Yeah.
we'll see.
I don't know. Sure. It's-
No, it's not. And then this is in the one in the intermediate one.
So we end up with minus f sine theta and alpha.
Shouldn't sine be negative?
Okay,
No,
so
never mind.
the cosine and sine just switch. So then with the cross product, what we can do is just change that cosine down. Yeah, that cosine just becomes sine.
Wait, but don't these change?
Well, they flip,
But the rest are zeros.
but the rest of it was correct.
Right.
So if they're flipping, then that's all it is. And I'm gonna do it on my thing right here. So
Can I change?
yeah, you can change it. I'm gonna just double check my calculator here.
Or fg is just mg.
MG.
You get
So
negative
that-
3/4 h. Well, then it would be positive 3/4 h.
Instead of r, it should be h. Is that what you have in the bottom?
I think so. Yeah.
Yeah, that should be.
Because H is a Z high.
I think
I'm getting positive 3/4 h mg sine alpha.
Yeah.
Is it supposed to be positive?
Well, we have the negative here, and then with the cross product.
Oh, it does
becomes-
make sense, right? Because it's moving it clockwise on
Yeah.
the y-axis.
So
We're back.
Clockwise is
Clockwise is negative.
counterclockwise is positive.
It is. It is.
It is
moving
counterclockwise.
It is
It is.
Yeah.
So it's gonna be in positive.
So it's positive.
So we're good.
Is it?
Yes.
right
If you hold
hand.
your thumb like this, and the
coil.
way your fingers are wrapping.
But the cone is
Wow.
the cone is being pulled to this direction.
The pull would be going in the opposite. Wait, where do you think?
Like it's pulling the cone down.
What term is being questioned here?
It's pulling it down, but the moment is a net cause. Oh. It's going down, but it's in the opposite.
Don't think about it. You guys move on.
Okay. So what do we have so far? We have the moment of inertia. That's done. We're multiplying that matrix by
That, right?
yeah.
Okay.
That's like what we have in the top right. You know, like you see in the top right, we have moment of inertia times another matrix. So we have the moment of inertia, then we multiply that by the matrix, and then we do the cross product after that.
Right. Are we multiplying it by the matrix we already
Yes,
found?
let's be making it.
Well, that's this term, then this is being multiplied by.
I don't know if maybe order doesn't matter. We'll see.
Wait.
It feels like
Are
order
you-
definitely
wanna
matters.
cross
So
product?
we want to do
Cross
cross product
product.
first.
This is just a matrix.
So you want to do the
operation.
cross product first?
So
We can do cross
no, we
product.
can't.
Well, yeah, I think you have to do the
We have to
multiplication.
we have to do this first, right?
Because you have to put it in terms of.
Is that right? At least I don't mind.
Can you look? Or,
Oh my god.
like, if there's a PEMDAS for cross product?
Should be configured.
I mean, that's what I thought too.
Like the 3/4 H or just sign alpha.
This cross product is positive.
Because of it's maybe because of how we defined our I. If it was into the page, then maybe it'd be positive because it's not really the page.
This sassy four post
I mean,
this,
the
it makes
axes are
no
not
sense to do
going
the cross
in and out of the page because if these.
Oh, like I mean,
Be
like,
clear.
if it were, if the X were.
It has to be negative.
If it was negative, then what direction would the moment be going?
Well,
Like,
if this is the X axis and the gravity is pushing down this way,
should be
then clockwise. And then this is positive, right? So then if it's pushing this way, that opposes the positive direction. So it should be negative. Is that-
It must be, but the math. You're right.
Are these the same? What? That's what I'm confused about.
Is what the same?
The two angular
the two
velocities.
They are the
matrix.
same.
So this is just
So multiply that.
matrix
by that.
multiplication of
Mhm.
this and
Yeah.
You can write that out.
Isn't that right? It is zero?
It is zero.
Yeah.
I'm not very good at
I'm pretty sure it would be all 0 in the I hat direction. It would be omega times that middle thing. The
So the middle
omega
term's
sign,
multiplied by
yeah,
that.
times the middle thing,
Right.
and then the other one times the other.
And then so
Like, one more comment.
Yeah.
Let me know what you guys think. I believe because so this is the rotation there about the Earth. This is the rotation about the center of mass. So should this still be E?
What do you mean?
Just
Because we're rotating about the reference
The
frame
reference
that we're
frame.
using for the
But-
top.
But isn't the
So
angular velocity of the body is the same no matter where on the body you are?
Yes, it should be.
But the direction, it's not along this axis.
Yeah, I get what it
Well, it's just notation though, because how we represent it is so fine. I feel like. But should it be omega t with respect?
T with respect to what?
Well, the frame of reference that we use for t.
Which
the
is not
primes.
it's her.
So T is top, like still top.
Alright, and then now I need to do the cross product.
Right.
Matrix.
Crazy.
Oh, this one.
No, go for it. You're on a roll.
I don't even know.
Flow on the roll. Keep going. We'll help you.
That's an I, right?
Yeah.
Okay. Yeah, it's just space. There's not a lot of it.
You can just go for it and then erase it and put it back. Like how I did
Should we do
it.
the cross product first?
Just go for it with the cross product and then erase it and come back. And put it back.
Okay, now just set the cross product.
I feel like you are right on the equation.
You can just write it out. Like I, J, K, and then just do the cross product, like all the terms.
Yeah, it's just a pain.
I'm trying to figure out how we messed up that number. Because it doesn't make any physical sense.
What do you mean how we messed up? Like the negatives or
Because it's about like the negative, the moment has to be negative about the I-axis.
Wait, so then wait, why did we do that? We split up the components into sine alpha and cosine alpha. If it's just along the x-axis and the x-axis is like the same for both, like x prime and x are the same, can't we just say that the left-hand side should just be your position, your center of mass, and then times your mg sine, or not sine alpha, I guess. Well, I don't know if it's still sine alpha, but
Yeah.
you can still say it's just along the negative I hat, because if you just do the right hand rule, you know that's true.
That is true. It should be. I think the goal of the rotation matrix is to define the force in terms of the I prime hat, J prime hat, K prime hat system.
The big H squared up here, that's, you can, I'm just looking. You see that? You see those pictures? Is that a 4? Or 3r squared plus 2h squared? Or is that an m?
I think the problem is that we took the moment. We're all thinking about taking the moment about the tip of the cone, but like gravity doesn't exert any moment on the center of mass.
Well,
the
are
force
we-
of the
wouldn't-
ground does.
Wouldn't you say that if you were to replace gravity with like a concentrated force, wouldn't that act as the center of mass?
So it wouldn't exert any moment.
Oh.
But-
Oh, so okay.
There would be a normal force because it's steadily precessing. There's no motion in the z hat direction. So like there would be a normal force equal and opposite to gravity upwards at the tip of the cone. So then this would become positive force, positive normal force.
So just going through really it's switching all of the gravity with a negative. And it still would be mg because normal force is just the opposite of gravity.
So that was the problem with our approach.
Okay.
Is that the same mistake we made last time? Or
We had the negative in front of that term. I don't know, did you cancel it out with the 3/4 earlier?
I don't know if
Is-
we understood why.
Can you tell me, you see the IC times the mini matrix, column matrix
Yeah.
equals the column matrix? In that column matrix, the second one, it says 3y squared in the y j hat area plus 2h.
Yeah.
4.
Oh, I see what you're saying.
So an h squared
Well,
is a 4
I
squared?
think this
It
is
has
an
2H, that's
That's
H.
an h, sorry.
Yeah.
Okay, those are h's.
Yeah.
Little
Yeah.
h, big h?
I think we've been using it interchangeably, but it should be little h.
It should be little h.
Oh, it's just,
Well,
Well, I
I
think
think it was big H on the side.
on
so
the but on the left side we defined it as little h.
But is it the same thing as the height of the cone? Because that's
Yeah.
what
Yeah.
little h is. Okay.
There should be functionally the
Okay,
same.
I'm just going to.
We're on the deathbed of all these mergers. We gotta figure it
So
out soon.
we used them
Okay.
all this semester. So.
Now that we figured out the mistakes that I made with the gravity moment, the normal force moment, I'm just gonna erase this.
I'm just gonna go through and double check everything. That way, in case
Okay.
you
Yeah.
do get another wrong answer.
Okay. And this is in the I hat
it's all
direction.
in the I hat
So
direction.
then we should get rid of that.
So now it becomes a scalar problem.
Scalar
Hooray.
equation. And now we know everything here except for psi dot.
So we want to isolate for psi dot.
Yes.
Yes.
Would it make things easier just to reduce the amount of algebra if we plug in numbers for everything other than psi dot? That way we can just easily simplify it
That
I would
sounds good.
prefer
and we
that,
can
yeah.
avoid algebra mistakes, because I think that's what we had problems with last time.
Can I use your calculator, or do you
Yeah,
want me to
you can
fill?
use it.
You want me to put Desmos coming out?
If, yeah, we can double check.
I got it. Triple check.
Two people with Desmos.
Triple check.
Third person with MATLAB.
Desmos for the. I have MATLAB on my iPad. We can do that.
So let's just go through our units real quick to make sure everything checks out. Here we have
I think
meters squared.
Wait, at this point, since is mass still inside the matrix? Or we canceled out
Yeah, we
mass,
canceled
right?
out mass.
You canceled out on the left side as well?
there's a little
It's-
red
it's-
line. It's so
Oh,
faint.
it's
Very
really,
faint.
really, yeah.
Everything's dying.
But can I ask who
What's
derived
the
this?
change between degrees and
The
radians?
moment of
180 over
inertia?
2
Yeah.
That was,
Is
I
there a
don't-
problem with it?
I believe
Why are
so.
you doing that?
what
Because
should it
we
be?
have
Cross-reference it with,
our angle and
like,
radians.
online.
We have the
Everything.
omega
Yeah.
and omega is
Omega.
That was from the
It's
textbook,
honestly
right?
they
Degrees.
multiplied it out.
I don't think so. I can check.
Well, once you put the degree angle in the sign, it loses the units, right?
There's no. Oh yeah, yeah.
So if you if it's given in
I don't
degrees, you
believe
do it in
the-
degree
our
mode
moment of
to
inertia
sign.
is
I think
Okay.
degrees are.
What do you think it should be then? Should be 3 over
Look
10?
at my phone.
Meters squared.
Look at my computer.
Okay.
On the left side,
Per second.
Daniel, for a number, if you want to write it,
Uh huh.
I got 280.996.
And the units are gonna be,
Meters squared per second squared.
Okay, if anyone would like to check
yeah,
what I'm looking at, it's on a physics board.
physics 1 got us.
Is it a solid cone?
Yes, it is. I believe. Should be the exact same.
Solid cone? It was a solid cone.
What, ours 1.2?
Yeah, well, 2 over 20 is not 3.
Yeah, it should be times 6.
Okay, for that
Is that-
first term, I got
Is that true?
well, I
we
guess
can
I
wait
didn't
until
add
we plug
together,
this in.
so don't listen to me yet.
Really?
We had somebody else who pulled up moment of inertia.
Yeah, it was
That was the textbook, right?
the textbook.
Really? Okay.
Solid cone? Well, it might have to do with the orientation
yeah, I
of.
think it's because
It's because the cone is
flipped.
flipped. Yeah, I think you're
Yeah,
right.
so if you flip it, then the new.
What point are these moments of inertia about?
See, it's
Center,
1/4
probably
there,
the
but we already flipped
Is
it.
it about the
3/4.
origin? What is
about the
it?
center of mass, probably.
About
About
indicated
indicated
axes.
axes.
Yeah, it's about the origin.
It's about the origin.
So we should swap them with inertia equations.
We had the right ones before last time we did this problem. You have them right here.
Okay, let's substitute them in.
I'm going to use this a little bit.
Yeah. We need to change.
You just change. You start with the.
So these terms get
matrix.
multiplied by 6.
So this needs to be 12h squared.
Can you change the uppercase to lowercase h as well?
And let me double check. But
Is that the only difference? Just the 12?
I believe so. The rest of
Okay.
it looks right.
Did that error propagate anywhere else that I'm missing?
Did you do the cross part answer yet?
The 2h is now 12h.
It's just about 12.
Degree. Because it needs to divide by 23 fifths.
Does that look right? Think so? And then it gets multiplied out twice.
We can also check by checking the units, right?
Mm-hmm. Well, no, that
Well, oh,
would
because
change.
it's
This one
just the
that changed.
coefficient front, yeah.
Okay, and Daphne also got negative 3.44.
The number, did you include the change in the
did
moment of
it,
inertia?
Because that's
We changed the formula now, so now it has like 12 in some of the terms.
12h instead of 2h.
12, 8. Okay, let me redo it.
So we're gonna have another number with meters squared per second squared. And then a coefficient for phi dot, or psi dot, rather.
Wait, almost there then. That's the thumbnail right there.
The butt scoop.
Just depressed, doing dynamics.
Okay.
Alright.
Do you want? Are you just checking it first and then you're gonna like? Are you just putting the numbers in?
I'm getting the numbers for him right there.
Okay. Did you get the first
I'm
one?
getting like negative
Well-
199.8.
For the term that doesn't have phi dot or psi dot in it,
I want to get that.
that's okay. Because
And
if
we're
gonna
doing
use
it
the other
individually, like we're doing terms individually, that way we make the algebra easy, because we're only solving for psi dot.
Okay.
So we're doing the first
wait,
term.
And do we have to put in the other side, like 3/4 G sine alpha?
side, we already got that one.
It's on the left.
It's 280 on the left too. Sorry about that. I'm getting
280.99.
What's the gravity again?
it's 386.4, and I'm
Oh,
not
hold on,
getting.
these are inches, right?
Yeah,
Yeah.
inches.
That should be inches per second. squared.
I'm not getting your number, Lolita, for the first coefficient, so Gracie can be the tiebreaker.
No, I'm
I think she did it overall.
yeah, I did it for
Overall.
everything, like
I
the
did
whole
overall
function.
as well.
So like, you solve for the answer?
Like 3/4 times.
Technically,
Does that
okay.
make sense?
If I did my
It's
numbers
on the
right,
left.
Daniel, I got negative 45 for that one. Yeah, negative 45.59.
Does the psi dot make sense? Inches squared per second?
If you divide inches squared per second squared by inches squared per second, you get radians per second.
Okay.
Okay. So I got an answer for psi, like overall.
We're doing it.
You want me to say it?
What is it?
Spoilers.
Is it the correct one? Let's just say that one first.
What?
Is
Is it
the
about
correct
200? Is it
answer?
about 200?
It's like two
No.
two.
It's
Nice.
not. It's
Maybe we'll pray that Lolita put it in her calculator wrong.
She printed decimals wrong.
here. Can someone just double check it?
I mean, that's what I think me and Gracie are doing right now.
No, like can someone check like if I put it in the calculator, right? I'm going off my image.
I'm just here to sit on the floor.
Yeah.
Okay, Daniel. Oh, for that psi term coefficient. Oh, I did. Yes, I did. 0.2011.
Oh, that sounds
I
close
think
to
that's
correct.
everything.
I don't know. Let's see,
That's the left side.
280.996
Wait,
plus
never mind.
45.59. I think
No,
I'm
it's gonna be
huge.
really big, is it not?
Yeah, it's gonna be huge.
I got around 500.
I got
1623.
yeah. I could have typed it in wrong though, so. If Gracie's the tiebreaker on this.
Oh god,
How's
guys.
it a tiebreaker?
That's a lot
Neither of you guys-
pressure.
You're the person who we have to get the actual answer.
Andrew's gonna
No, ignore the top one.
Trying to get the.
I do have to pick that up. It's the bottom one, not the top one.
Is my laptop dying? Probably.
Make sure everything is correct. How many times do we have P? Or
Riley, take over for a second.
you're getting
Oh,
big number.
We got out of focus. My
What
bad,
did you guys
guys.
get?
I got 1600-ish,
1600. Okay, I got 665.
and Lolita got 500. So maybe we're all typing it in wrong, and it's actually
Why are
200.
we all getting different numbers?
I have 3/4 H times G times sine alpha on the left. I have 3 omega squared times sine alpha times cosine alpha. There's that one.
You're in a degree mode, right?
Yeah. Hold up, I found my
Because
first
I don't think
one.
Desmos is default in degree mode.
Yeah, I clicked it.
Okay,
Cosine alpha on that side. I got 673. No. Times, having to do k squared because it doesn't like my R. All over that 10 plus 3 omega, that's where, nope, that's correct, by x squared sine alpha all over 10 minus omega squared sine alpha cosine alpha, that should all be divided by 20, why is it not? 20k squared times 12h squared, we now have negative 22. It's getting worse. Oh god.
And then did you do minus the second side term?
And, well, I have it all.
Oh, you have
this is
it all
added
minus?
together then.
Okay.
So then the next add is the psi dot sine alpha. Is that correct? 3k squared plus 12h squared over 20.
Yes.
All right,
You're
guys.
now the negative number.
Is there another negative number?
Well,
Or now I'm getting out a negative number. Yeah, negative 22.1303.
So the
okay.
first term?
K is negative. What is K?
You can retype it in. Did you get something
Okay.
different?
I don't understand. What's going on
We
from
want to
between
find what is K?
So he like condensed the two terms without side and the two terms with
K
side.
equals R, right? So K, what is R? 1.2. It might have been because it just had a negative number for my K.
Can you double check that you're in degrees?
Yeah, I'll double check. H is 2. Omega is 67, and then gravity is 386.4. We are in degrees, people, and we are now getting
Well,
think there's
you're
an
already
34,
Same here.
347.7.
I like how we all got different numbers.
So 347.
That's we're not
The
cheating.
thing
We're not
for
copying
me
off each other.
is gravity. I want to make sure that term's correct.
You know it in feet off the top of your head. Just multiply that by 12, right?
That doesn't get you it though.
Inches per
Oh.
second.
Well, 30, feet is 32.1.
What are you guys using this thing to plug it in? This
Using
bottom thing?
Yes.
There are like multiple algebra errors in here.
Is
Oh,
what
there
you're
are?
saying?
Yeah.
So which one do you say we should go by?
There, this
That's
That's
correct?
the function, right?
this is correct,
Okay, I'll go by that one.
but it's not
But it's not separated. Well, I guess.
separated. There's
we
only
can-
one side
What
out
do you
term
mean
here. The other
separated?
one just disappeared.
I'm plugging mine in like the
So-
side.
I think if we keep this.
There's
Oh,
two
wait,
side
no,
outs.
It's right here. It's right here.
Yeah.
I just lied.
I can plug in the one of
This
there.
is missing. What was it missing? Missing an omega.
Okay, I'll do the other one because I'm just typing it all the way in.
So make sure y'all calculate that.
Does that make that big of a difference? Doesn't that only change this term? Is
It will.
the side
It'll
term
change
was-
mine a lot. Mine will get.
It'll divide your answer by
I'm
7.
gonna try it
What,
again.
wait, what did you change?
So then it's getting teeny tiny.
What
Because
is-
if it's. Oh, no, it
you
won't.
have omega where?
Omega here. Last side out.
I think
We got negative 25.
I'd get a negative number if
Yeah.
that happened too.
Oh.
If
I
that
get
omega was
negative
there.
2. I get negative 62.
What do you get?
I don't know, but
You can run it. I don't-
Okay, we got
No.
negative 25. It's weird how, like, did we all put in the same function?
I like type mine out in a calculator, but I do it by steps, so I could have made the error
I'm
there.
gonna
But
go. So you're saying
These are supposed to be negative
What?
because when they're rotated about. Wait, can we do it all?
What should you make it?
The sine term, like these two.
Okay.
Are we allowed to cross-reference the kids from last year? Like their video?
of course,
I probably should because we are supposed to be technically.
I don't
Somewhere else
know.
right now.
I'm not an expert in rotation matrices, so maybe we messed that part up.
I think that's why.
I think because when we rotate it this way,
Is the angle negative?
the x-axis component of this is clockwise, but we have positive defined as counterclockwise.
Oh, okay. So, are you saying that, like, in terms of like how we did the transformation matrix, We did it with positive alpha, where
Probably
for our
negative alpha,
rotation,
right?
it should be like we did it like in the negative direction. So you're saying when we did the rotation matrix,
So
we
the-
should have had it.
The cosine terms would be the same, but the sine terms would be
Is this
opposite.
the rotation matrix?
I believe so.
Is this what you guys wanted?
Because the cosine is the same, where like you know you
Oh,
flip it
yes.
and the right angle is the same as the rotation.
I
But
thought we used-
the
I
added
scroll down.
sine
We use
component-
one times.
Someone want to respond to Ivan?
Keep scrolling.
We're a little held
Say,
up
It's
here.
below. It's
When
the
you
direction
figure
cosine.
out this dynamics problem for us,
More
then we can go to dinner.
We used this one right here.
Mhm.
The thing is, we assumed it was like positive, like.
It definitely, the alpha's definitely
Ivan
negative.
wants to go to dinner.
What happens if you plug in negative 29 for alpha
For
instead
what?
of 29?
I got you.
For cosine?
Or no, for just alpha.
Negative 29 for alpha.
It should fix itself.
In the overall equation.
Yeah, I still get negative 600 or negative 63. I don't. It didn't actually change anything.
It didn't change your answer.
No. Like it actually. That's kind of crazy. It didn't change anything
At all?
at all. Let me see if I click out of it. No, it didn't move. Didn't budge. Something budged out. I accidentally.
Quick question. So
Yeah.
in our momentum or in our momentum formula, did we put I omega times d of dt omega no
IC times dt of omega, we cross that out because the dt is 0.
there.
And like.
Yeah.
So that whole term is canceled out.
Yeah,
because we're in
Did we
steady
put in
state.
A for that one? Like these two terms are different, right?
Yeah, I don't think that formula is right. Like the one I pulled in the slides is the one that we used.
Yeah, but according to this, the two omegas are different. We'd have to transform one and not another.
Isn't that what Andrew was saying?
Pop up Andrew. Shout out Andrew 20 minutes ago.
To transform omega.
Maybe one of them doesn't have the side eye.
You say take side out? We just started doing
Special
it.
guest Ivan coming in to help us out.
Fresh out of the
I
hospital.
didn't.
I don't know how.
Okay, so which side out would disappear?
That one.
Which goes into.
Everything.
Yeah. Would it be that one on the left side?
This one?
Yeah. So then I take it off of the left, and then
Yeah,
I
it would be-
leave the
it would
one on
be
the right.
left.
We're just gonna, you know what? We're gonna, if it doesn't work the first time, we can always just take the other one out.
Omega b.
And that's my X.
What?
All right.
That's literally what I just said.
Still negative. How is it that that's now it's 52? Negative 52. Okay, we
What,
multiply this one again.
222?
Hold on. Should I get rid of the side? Do it
And
again.
then we'll go on this side. Yeah.
So we're getting rid of the side in the second part, like before omega.
This
Ooh,
one?
so I got rid of the one on the
Yeah.
right side.
We're getting rid of
And we're
the
getting
side.
322. We're back to positive.
That's only 100 off.
We're closer.
So what if we
50% off.
subtract 100 because we feel like it? And then there we go,
feeling
right
spicy.
answer.
Wait, isn't our thing have to be 222.4?
Something like that.
Yeah, see, exactly 100.
So subtract 100. So because we are A students, we take
we
that
get
100% and we subtract it.
Straight up.
All right, let's low key fix it though. What?
Low-key.
let's-
You mean we're not just going to randomly subtract 100?
My iPad has subtracted negative 20%. Maybe we should take all the percentage we've lost while doing this, and then subtract it. That might be 100.
Oh yeah, like camera. This is a 54-minute video, which is almost an
Oh.
hour,
It's like
which is
phone.
like 100% of an hour almost.
We spent 2 hours. It's a normal class time.
All right.
I'm
So
trying to find. Yeah.
This? Well, when you take the derivative, the perspective you take it doesn't matter, as we said.
Mm-hmm.
Yeah, and HC is. What is moment of inertia around?
HC is angular momentum.
Yeah, but
Right.
it's at C, so it's like that's the center of mass, which is different from well,
No, that's the angular. That's saying the angular velocity of the body with respect to inertial reference frame, which we have here. There was a formula I found in the slides that was like exactly what we needed. I'm trying to. Maybe I should. I don't have my computer.
You can use this right here. iPad's further away. Can't believe I came in a notebook person and I'm leaving here an iPad person.
Wow.
It was like a last week transition
Wow.
though.
Really?
It
Oh,
was.
is it look like this? It's kind of it's not.
Lolita, what equation did they use last year? Is it any different than ours?
It looks the same except for just
Oh, is it this?
omega A is the middle.
Yeah.
Okay.
Intermediate frames of reference for axiometric props. That's exactly what we're doing.
Okay.
G is our intermediate.
Mhm.
But the
And there's
thing
G nowhere
is
there.
isn't that what we have?
Yeah.
So we have it in terms of what they are calling G, which we call I.
So these two terms do look the same, do they not?
They
Yeah,
are
they
the
are the
same.
same. So that's not it.
E's and STL, intermediate G, frame of reference.
Or is it what's on the bottom right here? Because that's different. Those are two different terms.
These are two.
That was what Andrew was saying.
That's what Andrew was saying.
That's the intermittent G.
Oh,
frame of
okay.
reference.
So if we are looking at this problem in the like the intermediate reference frame coordinate system, they are different and how.
But Andrew said that would just be the notation, like the.
Quick correction. Wait, actually I have a question. Why did we put 3/4 mg
That's the
sine
center of
theta?
mass.
Yeah.
They do the same thing with the
Because it says RF sine alpha, and
Yeah,
like
but
F
F
is
is-
mg, right? F is mg, but we need RF sine theta,
But
not
R is
sine-
just 3/4 H.
What?
R is just 3/4 H.
Well, is it like, are they using R in terms of
Wait, so
radius
what's-
when they plug it in,
what's
or
the
R in
No,
terms
they
of.
replace R with 3/4 H, which is
So
not-
this is now the velocity of the reference frame. Wait, what? W of
what?
G, C with respect to I.
That's G with respect to I. G.
What does it even mean?
So I.
That is the inertial frame.
Earth
So there's the top and there's an intermediate one?
intermediate
And then
is
the
I. Inertial is Earth,
Yes.
and then the top is a body.
Because I think we need to
Well,
go.
you mentioned math.
T.
What are we
You
calling
can cancel.
B?
You eventually cancel out mass. That's why they let you use it as one graph.
So
Okay, got it.
the angular velocity of the inertial reference frame with respect to the Earth is just, that's the correction that we just made, right? Is that for the purposes of the cross product, this doesn't include the spinning of the top about its axes, it's just the reference frame. Because the reference frame is not spinning about z hat. So if we say,
You're taking away that addition.
yeah, but we already tried that and still got the wrong answer, right? Oh, hold on. I erased one too many.
Wait, so we're saying E is our inertial frame, I is our intermediate.
Yeah,
Okay.
that's a little bit confusing. Sorry about that.
just a little. So wherever they have G, we should have I.
Yeah.
Yeah. So
Sorry,
Yeah,
guys.
the same transformation matrix.
what is the transformation?
Maybe instead of going to dinner, we use the modern dinner from the restaurant.
No, I'm excited about dinner. It should be tasty.
Are we? Well,
If we had gotten there at 6:30, we would have gotten the fuller version.
We have 720.
Remove the
tragic.
Is there sushi?
Do we have the like an official reservation? Is that like a place where like could we walk in?
We have an official reservation. That's okay.
But
I
like,
think I fixed it.
It's technically at 6:30.
No, that is the same room. You said we get the.
So you fixed
So
it.
I just get rid of the other side up turn.
Yeah, then that's 320.
Get rid of it completely. Like all of it.
Not the one that was here.
So 12
So I can just erase that whole plus.
So it's 5. So it becomes.
6 over 10, 3 over 5.
Yes, that's better.
and the dynamics problem is too hard, so you just hide in the corner.
316.
Yeah, we got it.
Well, at least it's
And we got that for omega.
Well, we were up to 322, so we decreased a little.
Negative omega
So
sine
this is with a negative alpha. If I change it to positive, it is, drumroll please, 316. 316 is something.
It's closer.
Yeah, negative J.
So you're saying our J should be negative.
which one?
For this one, this should have been negative according to.
So we messed up the rotation matrix. Oh yeah, wait, hold on. No, that's what we were talking about before. We
So
said
it's like
Yeah.
we said that
Bring it
the
down.
alpha was
our
negative.
alpha is going in the negative direction.
So if we say alpha is positive,
Bring that down. Bring it down.
can I'm right.
Too much hassle.
Another shout out to Andrew for that one.
Yeah, Andrew's just
Andrew like had all the whiz, and then we just disowned him, and now he's like amazing. And he has
Yeah.
earbuds in, so he can't hear any of this. Oh, he has one in! Yay!
You're doing some deep research right now.
So basically everywhere with the sign just turn negative.
So every sign is now negative.
Every sign?
Every sign.
Okay.
Yeah.
Yeah, that sounds right.
That makes
Well,
sense if you look
you
at
have,
it.
You have 2 signs squared, but I don't think.
What about the sign on the left side with the, no, okay. 276.
That's
We are
50
getting
off.
somewhere.
We're from 100 off to 70
276.
off.
What about this? Oh, no, that goes right back. Okay, don't do that.
we're only 50 off, not 100 off, Nefez.
And omega B, we got that.
It's the same, right? Like these two.
Andrew's gonna pull out another one for
Come
us.
on, Andrew, you got it.
Omega AB
Andrew's
is on
cooking
the
right
left.
now.
Omega EB is on the right.
Is he
Yes.
cooking or would he be sauteing?
He's in the kitchen cooking like a stir fry. See, he cooked it
Yeah.
and then he devoured and then he ate. He served, devoured, then ate.
You know who really cooked? Daniel teaching me how to code freaking Desmos. That
Well,
is a, look at this. Look how gorgeous.
That's the thing on the right.
I'll zoom in for the video.
Yeah, zoom in.
Oh.
Times that matrix.
Oh my god, wow.
This is what you get.
This is like vlogging.
I'm like presenting this stuff. You're just like sending the rest of class the
He
video.
wants to see our process.
Because we ran out of time in the semester by like probably 3 class days.
I
Well,
thought we were ahead of schedule.
We were, and then, I don't know.
And then we weren't. It was probably too luck. Too luck kept changing the schedule towards the end.
well, we never like
Like,
missed a full day.
What?
We only missed an hour this week.
Yeah, that's right.
Yeah.
So like, oh no, I'm lying. No,
No, we made up all the time.
didn't we miss an hour? Oh, because we started at 10.
Yeah.
So
These problems are different from the ones last class had.
nope, we just can't even understand their work. We're just built that different.
But don't worry. Next year, they got it.
The fifth,
Walking them step by step.
the Fizz and Lolita are on that.
Awful mess of videos.
Well, I guess we just.
Started with like 5 videos, and then that had to get deleted. So
Luckily,
going
we're
to
an
like
hour
5.
and 5 minutes
All
in.
fun together though, so I don't think that.
We might have to call it eventually though, because if we
Do
want to go to
you want
dinner.
this? Because I think
Din din.
until here we're definitely right.
I I don't know, you probably saw
So
the
if we
text,
just-
but your
if we
mom
do
did
the
text
cross product,
you
maybe we can find out where.
that the dinner reservation was
We did
moved.
cross product.
Or WhatsApp.
Ah, just moved it to 8. Woohoo! We got another 30 minutes. It took almost an hour to get here. Boo,
So-
we now have 10
no,
minutes.
No, this is right. And this was just straight up our inertial matrix, which was correct. And we multiplied this by our
If anybody,
This.
well, everybody here, well,
So,
you're not in this class.
okay.
Well, he can
I
help.
was 0, right? This was
Cross product.
You don't even get a break. You have to help us.
You have to help.
This is what they Yo,
That's
this is
mine.
what they put.
Do you mind if I write something?
Oh, yeah, sure.
Do you want to use
Like for
Skype?
this one?
I technically am doing work on it though. Like I had my work pulled up.
cosine alpha. Omega, yeah. Plus phi cosine.
Hold on.
That's the same term.
That's the same.
Well, we have a, yeah, that's right.
This one ends up being positive. Omega squared cosine phi sine phi.
What if the last
times
didn't get it right? It just was the correct answer down. Because that's what one of them did on one of the other
Omega squared, we didn't get the square.
Really?
Yeah,
Not for the last
Here, omega there.
question, the mic cut out. And then you can't see it. So I kind of had to do it on my
Yeah,
own.
this is just our.
And I used internet resources that I don't know if they were right because I don't remember that equation learning it, but I get the right answer. So
watching one of the
So
older
that's
people,
right.
they were like doing the
This is
process,
right.
and the process was
This
right,
part?
but their numbers weren't right,
we
and like
tried
they
isolate
switched something.
for
And
the
I was
side.
like, that's not right. How did they still
Yeah,
get the
there's
correct
only
answer?
one,
The girl just wrote it in.
Only this one.
there's one guy that would always like carry. Like if they got confused, he wore a pink sweatshirt in a
That
couple
is the
videos.
Fez
Yeah.
and
Add this over.
Daniel
yeah.
for us. And Andrew.
And yeah, Andrew's silent but
When
deadly.
Andrew has energy and is ready, he can crack it out.
Let's do sine. Squared.
Don't sleep on Andrew.
Took out the n.
Andrew.
We have r squared. Cosine alpha. This one's right. That's 3
We got the same
phi.
thing. It's
Where did
probably
we
a
get?
sign.
Is that? It's supposed to be
That
this.
cancels
This
out.
is this term.
Yeah. I'm trying to figure out what I can do with sign error.
Sine. Why do we add sine here?
What if the problem's actually impossible and it was all through
I
teamwork?
think cross products is that what we're looking
If the
at? Is
problem's
cross product
impossible
boundaries?
Plus or
and
minus.
Professor Dinesh wanted us to all work together as a
Is this a
team.
plus or a minus?
Is this a plus or
You
minus?
never know. You never know.
Got it?
That is.
It's a plus. It looks
A
like a
plus?
favorite plus.
So then we distribute it to negative, so it becomes
So
minus.
this
here.
one should be a minus. Is that it?
No, it's a plus. That's a plus.
This is a
there.
plus.
So then
This
that.
should have been a, this is a minus, so then. we're
That is a
distribute
minus
it
for
and
sure.
positive.
And then.
So which one is positive? That one?
So that was right. We had it right.
So we had it right.
Next term, we'll just add.
What is?
What if we just don't distribute it and just put this in the calculator?
Try that.
Put that it does.
Is it possible we're putting
Omega wrong or units wrong? When we're doing the.
Or can I
This
put
one, yeah,
this
this is right.
verbatim like this?
Do you want me to do the cross
Yeah,
product
yeah.
again?
Yeah.
Just to see?
you just rechecked it and it seemed fine.
You did? You recheck the cross product?
Okay. Negative 7.016.
I really said this would take 15 minutes max.
I said that's not long. Where does that U come from?
Yeah.
Tillich's coming in for the save.
Yes.
Last minute,
Nah.
coming in for that save. Ringer, buzzer beater, 3-pointer right now.
Yes.
Hit it in.
No. Up, right. We're taking the cross product for that thing.
Oh,
There's
here?
mass in there.
Yeah.
That's-
But
Wait,
is it
what's
on the
the
edge?
edge?
Because the edge is what I'm looking at.
Isn't mass just one?
It
Mass.
should be.
Oh, that's
You're
not
gonna
okay.
pick one.
Okay.
Yeah.
Yes, I guess that's it, right? This is it.
Yeah.
So that's a capital N. I thought this was an
It
H.
looks like Gracie's iPad has got a low battery warning from afar.
5%.
I know,
That was within 2 minutes. From that camera.
Nefez
It's like
is
more like 8. Oh, look, shut up.
Your pride?
Yeah, I just finished my final.
Congrats.
Surprise, guys.
Final.
Yeah, system dynamics.
I'm okay. You know what I'm gonna test out? My theory that that is actually an H and not an M.
Where would the H?
Which, where?
That's why I'm so confused.
Wait, where?
I'm confuzzled. The 3/10. Is it psi?
Psi.
Yeah. And then keep going. Next. Yep. What is in there? What is it?
Psi mr
Radius
squared.
and radius.
I was hoping it was
Sorry.
No, you did it correctly. You shouldn't be apologizing.
That's hard to read.
God, VT, stop doing your work
Why are you
correctly.
So perfect.
Ugh.
So the equations y'all have in Desmos actually match this
Yeah.
or this.
Okay.
It matches the new one, whatever we want. Could it be that the plus of my thing is really hard to read, and so like we didn't get the plus, or?
We're gonna run out of markers.
I'm gonna start narrating this like a nature documentary.
Yeah,
Nefez
there.
approaches the
I
board.
think I found it.
He's writing with a
Isn't this supposed to be
red
plus
pen.
Where did it go?
This?
No,
Oh,
that's a
remove the
different.
plus sign here.
Why?
No, that one's supposed to have plus side. That's
This
just-
one?
It,
I thought this is different from this one.
it is. They're the same. Like they're different, but look at what that is. It's the inertial matrix multiplied by the omega. It's just written in a confusing order on the board.
That's even better. Okay, give us the blue dead.
The blue one is dead as
Great.
well.
Daniel helps from afar.
I have a black one in my
These
backpack.
students are low on markers.
Okay, yeah, you get your red one, please. Please. Yes.
They are low on brain cells as well. Yeah, it fits a bigger one too. Yeah.
Isn't it neat? If only it was a better eraser.
Yeah. Why is it like bumpy? Like the magnet has fully like
It's been through some
gone.
It's now in
You
Morocco.
got the 9 term defense.
Yeah, that's
That one's about 9.
This one's about 9.
Negative
Well, it's
9.
Negative 9, yeah.
Negative 9.
Yeah, that's right. That part's right there. Obviously. This is 3/10 times r squared is minus
Obviously.
Obviously.
1.2 squared. It's about minus 0.432.
Okay, that's like pretty close to what they have.
Yeah. Well, shouldn't this be exact? It's 3/10 and a radius. Like, we didn't make any approximation here.
Hold on, let me look.
Ooh.
Wait, okay, this guy.
No, you have to multiply
There's
by
drama
the
in the
sign.
villa.
Defense.
Oh, by this, right?
Yeah.
Okay. So you multiply it by omega sign
I can do it.
times negative omega sign.
That's it. We're doing another one.
Sign 29. You get about 1.465.
Yeah, they have that as a negative though.
Well, if you multiply, oh wait, this, like,
That's a plus sign. It's
This should be a plus sign.
impossible to see. So that's positive. Do the last term.
can we get like a pencil at this point? Like,
Tulok's coming back with the
A
marker.
Sharpie.
oh my
It's our last
god.
day.
This is like an eraser now.
Alright, just
Wow,
check it.
the black
Check
one
it
does
out.
it?
Mark
Try to
were
trash
literally
me.
brand new, and we ran through them all.
Do the last.
That's not hard to believe.
Come on, let me write the first term that we had. It was about negative.
Does somebody calculate the gravity term already?
Like this term. It's
Yeah.
right down here.
Oh yeah, that's right.
Someone hit the laptop.
I got it.
Nice.
I'm on technology duty right now.
What is? I thought we. Wait, so we have mass on the right side as well? Did I already know that?
Where are these zeros?
Oh, we canceled them out.
All the masses are like 1.
3.996.
I'm gonna put this. I'm gonna make a new one that's like what he's working on right now, and see if that's our issue.
I got negative 160.2.
Okay, that's not
Exactly.
good.
I think we have the right answer. Is the
Let's
last
go.
term wrong?
1.69.
Can I ask why you took out the sides from the cosine?
So
This term is
you mean
But it was
on the other
plus
omega?
plus psi, right?
The
I literally put that verbatim.
in the first omega on the left before the cross product, or
Is that
part of the
3?
cross product?
Yeah.
It's part of the cross product.
Yes. So it turns out when you use the intermediate reference frame, the formula changes a little bit, and the first omega should be the angular velocity of the top, or the angular velocity of the intermediate reference frame with respect to the Earth, not the
Which
top with
is
respect
which
to
is
the Earth.
omega.
which is just the omega. It doesn't include the psi.
Right. Okay. Makes sense. Is that what that's what it means when it's additive, right? Because you're adding the intermediate state or the new.
You want to try it? I banged it across the desk a couple times, so maybe that gave it some more ink.
No.
Is this
Okay.
the new one that we can just go?
No, Tilex gatekeeping that.
So what? Why are you gatekeeping this work?
Sorry, I'm on the phone with someone important.
Guys, I'm recording the president, guys. Give me a break.
Whoa.
Alright.
Does that be about 54?
Is that?
Yes.
Wait. Okay.
Yes.
Is that a 5?
Plus?
5? I see 5.
No, we have the right answer. I think Yona's
Okay.
really bad
Oh,
at
it's
like
omega.
the calculus.
VT, throw this all across the room
Maybe
into the trash.
5.
That's your goal.
So if we.
I'll follow the arc.
Can
Oh.
we have the good marker now? Like, don't we have that?
It's right there.
Okay.
God.
Nefis is
I've had it.
fuming about the
I gotta
marker.
pack up my stuff. I gotta like.
When is your
When are you leaving?
No, I like 1 a.m. But it's like I gotta launch to pack up.
Okay, maybe.
Can you erase this? Is that fine? Can I erase this as well? No.
stressed out.
Yeah.
Just erase it. Okay, don't go
Yeah.
back farther because I'm still copying
Yeah.
that right term.
So what we
Is that
have so
3
far
hours?
is that it's gonna be equal to. This one was about -9.
Does anybody know if they have
Nature
competitions
documentary.
on them? I am dying.
Okay.
I have some upstairs. I'll go
The
back.
animal named
That would be
Nefez,
great.
whose
Do you
name
mean
Nefez has
Gratitude.
started to behave aggressively due to lack of resources in the markers.
He's taking control of the situation.
He has now gotten a new marker and seems in a much better mood.
Where did our checker guy go?
One is abandoned.
Why am I getting it in the extra? No.
Daniel has abandoned the group.
How did this go negative? What is going on?
One of the females looks very confused while looking at her device. She has learned how to use tools.
It changed my omega to 4 point. Okay. That's the one bad thing about Desmos is it'll like if you accidentally hit the slider, it changes it.
That's fine.
Why is it doing
Thank
this?
God we have less numbers. That's way more better.
How come I put M in? I
Can
put
we get
H
someone-
in.
Check this.
Okay.
What's the answer?
Oh, I'm getting 4,000.
222.
Oh.
That's not 4,000.
Girl, what the?
A new male has arrived in the tribe named Tuluk.
My brain is fried right now, so I'm just trying to catch up with what it
We
is.
are all fried.
If we did cook, this one should be. When you distribute this negative over here, this becomes.
Oh, I never said it equal to anything.
So. Is that fixed it? I don't think I fixed
What
it.
did we say the left side was? 2089. Is it 20? Is it wait? 280. Is that
I
.996?
get you it. I think
This is negative.
Guys, I'm still getting
Well, this is
267.
negative.
that's positive.
It's negative in the.
If it's
It's in the
negative,
negative I.
I got you
Oh.
guys. I got you. I got
Okay.
you.
Got it.
So
Got it.
this direction should be.
If it's
flipped.
negative, then we get 307.
So we had negative
It's
up here.
222.257 and then negative I had direction.
Oh, we just
Whoa.
carried. We not carried.
I
Let's
think this is a
go.
later edition.
All right, just show the screen.
Hold on, I need to add the directions on here because that's why I got it wrong. Negative I have.
Oh, that isn't exactly right. Are we okay with that?
What? What is
What?
this after that?
We're off by a tenth.
That's because we rounded obviously,
Okay.
so the numbers.
Yeah, we this number is slightly off from last year. They got 280.7 or something. I don't know.
Okay.
We
Shout out my calculator error on that one.
Can we? Okay, once today, I'll like straight up leave or is he come back?
He's coming back.
Okay. We just have to go over like the directions and why they are the case.
Lalita.
Oh.
Yeah, that is a better marker.
I forgot to.
How long have you had that marker?
Me?
We've been
That
dying
is
with these old
1,000% gatekeeping.
Gatekeeping. We should.
Gatekeeper
permanent
to
one
look
there.
right here.
Oh, permanent. We should leave our mark.
Nefez already graffiti the chair.
Nafes,
Very
do you-
good.
Nafes, should I write something here?
Why would he do it on his shirt?
That's your tradition in India. The last
Yes,
day of
you
school.
did.
Let's round it to 3 sig figs so we get the right answer.
Yeah, round it to 3 sig figs.
Okay. 2. That's fine.
Right.
Wait, but what are the
Units.
is it this?
It's radians per
inches.
second.
Well, the radians go away.
It's supposed to.
Right?
It says the problem. We have to find it in.
Find the rate of
per
spin.
second.
Oh, yeah, good point. Okay, never mind. Don't listen to me. I'm done.
The units.
Good job. That at least you
Did
remember
we even
something.
check our units?
We should read the
We
problem.
did check our units. We did.
Are we sure we did?
We did. Why is it in the negative I hat? I'm pretty sure it's positive.
3 sig figs.
It's close.
How is it negative I hat?
That's what I'm saying. It's supposed to be positive.
Is it? I think the final answer is supposed to be positive.
It's not.
This
It's not
is-
negative.
We got a negative.
Oh, okay. So we.
Wait. If this is negative, right?
That
You
is
move
negative.
these two
He's doing
terms
both
over,
this
it's still
entire
gonna be a positive, like, this is still gonna
This
be
is
a
100.
number.
No,
You
that's
divide
not
by
how
a
time
negative,
works.
so
An
your
hour and
positive
21
becomes
minute
positive
video.
I hat. Does that make
Hour
sense?
21 minute
When you
video.
have 280 on this side.
I wanted to say
divide
121
by
minutes, but
54, that's still above 100. You divide by a negative number.
Okay,
it's
wait.
the sign.
Wait.
I'm at 2% on my iPad. This thing is dying.
Yeah.
it's like the escape room. How much percent oxygen you have
Can you
versus.
explain why
It's in the
this
negative.
We got it! Woo!
Well, because I find it.
See, finally,
Thank
when
you.
I show up, you saw the problem. So.
It's because the marker. It's only the marker.
So it's
Your
signs
marker
that.
clutched up.
Your marker
So
was
I brought so much stationery with me. I've not used even a single thing.
So the main thing that was the problem was the signs. So apparently the left side is supposed to be in the negative I hat direction, which is our force. We had it as negative here, we didn't have it here. We should just keep it consistent on like why was it negative?
I thought we explained why it was negative like 45 minutes ago, right? Oh, you're just summarizing?
Yeah, I'm just
Sorry.
saying like we should have been more consistent with saying why was it negative at the start. And just have
Right,
it
thumbs
here.
up.
Does someone want to do a brief overview, or do we think that we have enough footage?
Can we just write down the
We
negative?
do a review.
This should this have been negative?
Yes.
Notation thing.
Yeah, just keep the notations correct.
The
Is this negative?
Yeah, I can breathe.
psi dot is not a vector. It should just be a rate.
It's an angular speed, right?
Yeah.
Here, can I have
Yeah, we got rid of the directions before, like always are here with there's one
Finalists.
Look,
Look,
yes,
it's
and
hard.
it's at a rotated axis. So to start off, we have the formula of moment, which equals to a moment of inertia times omega in the initial reference frame, and then it's plus omega, the transformed reference frame, times omega in the new coordinate axis. So yeah.
Okay, so when we're defining this moment, we basically talk about it in terms of the gravitational force acting upon this cone. I believe what we decided is that when you concentrate gravity into like a concentrated force for this body, it ends up acting upon the center of mass, which will not cause a moment. Because for a moment, you need to have it activate at some sort of distance away from it. And so when we're considering that, we would consider the normal force as acting in reaction to that. And because of that, we can see that the force will act upwards and it will curl such that when we use the right hand rule, we'll get a negative value for our force equation, where we're taking the center of mass as 3/4 of the height up along the I hat direction. or along the z hat direction, or the k hat that we have listed up here. The
K hat prime.
Yes. And so then when we did the cross product along with the components of gravity acting in those corresponding new frame of reference, we get a final term of -3/4 h times the gravitational components.
So continuing on, we then focused on our omega times the inertial matrices, and we found that, and this is our transition, right? So our transition with reference to the inertial thing.
It's top to intermediate.
Hold on, that's
Is
not
it- no?
right. It's
Did
that angular velocity we found out through our process and checking the formula on the slides again is the angular velocity of our intermediate reference frame with respect to the Earth fixed reference frame. So that only includes the precession rotation around the z hat or the k hat direction in that's in the Earth reference frame.
Oh.
And that means that it doesn't include the psi dot spinning element of the top, which is included when we consider the angular velocity of the top with respect to our Earth fixed reference frame.
It's I to E and then T to I.
Yeah.
T to I?
This one is. Yeah.
No, T to E, it's T to E.
That's what
That is.
Yeah.
Yeah. So the
T to
difference is
E.
that this is T, this is I.
Yep. So that was something that we learned throughout our process. Then we found our mass moments of inertia of the cone about its center of mass based on formulas from our textbook. You can see those shown in the matrix there.
And we can talk about why it's not in terms of 0.
Mhm.
The reason why it's 0 is because we have planes of symmetry. So that makes it so that the products of inertia go to 0, and we're only left with the mass moments of inertia.
And then we took our angular velocity of the top with respect to the Earth, and we multiplied it by our matrix, and then we used that, we crossed that with the angular velocity of our intermediate reference frame with respect to the Earth fixed reference frame. And then we ended up with 3 terms, one of which had psi dot, as you can see. Or 4 terms, because we have our moment due to the normal force on the left side of the equation. And then, since we know everything except psi dot in this equation, we're able to plug in numbers and then solve for our final answer, which is 222 radians per second.
Good job.